So, good day everyone. Today I will present about the structural components at the bow and stern regions of the ship, which are some of the most critical areas in naval architecture. The bow is the forward section of the ship. It faces the harshest forces at sea. Waves, slamming and water pressure. The stern, which is the aft section, is equally important as it houses the propulsion systems, the propeller shaft, and the rudder for steering. Together, these two ends of the ship must be carefully designed and reinforced. The structural design of this area focuses on three main goals. First, to withstand pounding, which is the slamming impact when the ship pitches. Second, to resist bending, which is the in and out movement of shell plating caused by water pressure. And lastly, to provide safe and stable support for propulsion and steering systems.
Assalamualaikum and very good morning. My name is Adit Al-Azim. My matrix number is 01 DKP50173. So I will present for this slide. Let us begin with the bow section. One of the major problem at the bow is pounding. This happens when the ship have pitches and the forward region slams down into the water surface. To prevent structural damage, naval architect provide additional strength along the forward 25 to 30% of the ship length. This includes increasing the thickness of the shell plating near the keel, reducing frame spacing, and installing solid floors at every frame space. With longitudinal framing, the spacing is reduced further, and intercostal side girders with transverse floor are added. Another challenge is painting. The in and out movement of the shell plating as wave pass along the hull. To encounter this stiffening is provide over 15 to 20% of the forward length. We use painting stringers which are horizontal girder fitted about every 2 meters below the lowest deck. These are supported by painting beams fitted across the ship at alternate frames. All bracket to the stringers. Additional support comes from the wash bulkhead or central line pillars. Sometimes perforated flags are used with holes to reduce water pressure. In short, the bow is strengthened with thicker planting, closer frame, painting stringers and beams. All of this ensure the part of the ship can safely cut through wave while resisting both pounding and painting. Thank you. My friends will explain more in the next slide.
Assalamualaikum. My name is Muhammad Luqman bin Muhammad Rujahan and my matric number is 01 DKP23F1011. Now I will continue the presentation. Moving on to the stern section, the key component here is the stern frame. This structure terminates the shell plating at the aft end. On single screw ship, the stern frame usually has a central bolt for the tail shaft to pass through and an aperture for the propeller. It may also provide support for the rudder post and hintel engine. Without proper clearance at the propeller blade, vibration could damage the aft structure. So careful alignment is very essential. Next, we're going to talk about the stern frame. The stern frame connect to the other structural members such as the transom post and the vibration post, which help reduce propeller-induced vibration. Floors at the after end of the ship are attached to different parts of the stern frame, ensuring strength and stability. In twin screw ship, the stern frame is smaller since it only needs to support the rudder pillars. For very large ships, cast stern frames are sometimes manufactured in two parts and joined by welding. Finally, many modern ships use a transom stern, where the stern frame directly supports the flat stern plating. Well, this design gonna provide a strong, efficient structure for the housing, the propeller, rudder and steering gear. That's all from me. Thank you.
To conclude, The bow and stern are not simply front and back of the ship. They are highly engineered regions with specialized structures. The bow is designed with reinforcements to resist pounding and bending, ensuring safety and strength in heavy seas. The stern is designed to house and support propulsion and steering systems while reducing vibrations from the propeller and rudder. Together, these structures guarantee the safety, efficiency, and durability of the ship. As naval architects, it is our responsibility to balance strength, hydrodynamics, and functionality in these critical regions. And that's all from us. Thank you.